Can you all hear me? Please confirm whether I'm audible or not in chat. So let's start the discussion. Um, so in today's lesson, we have to go through the revision paper number 4. So we have completed 4 revision papers with this paper. And 4 booster papers, right? So in this discussion also, I'm going to start with the MCQ paper first and try to discuss most of it and then move into the essay and structured essay questions. Okay, we will start quickly. Again, hope you all can hear me. If there's any issue with my sound or the video, you can just inform in the chat. Okay. Okay. So revision paper 4, part for the physics 1 MCQ. First one, from the following physical quantities, the units of impulse is equal to the units of. Okay, so impulse, if you take the definition, impulse is nothing but a sudden change in momentum. Okay? Impulse is sudden change in momentum. So it's kind of type of momentum. So impulse have the same unit of momentum. So the answer is the third option. Second one, if there are any questions to be followed, please raise them in the chat. Then I can answer them when I go through the chat. Okay. Velocity time graph of two objects PQ is shown in the graph. The variation of velocity of P relative to Q is best represented by. Okay, so velocities of P and Q are shown in the axis. So velocity of P is something like this. Velocity of Q is negative value, that is negative U. And speaking, both these velocities are measured respect or relative to the Earth. So when there is no any, if there is no any object to which relative velocity is considered, then we consider the velocities are measured relative to Earth. Okay, so if you here they ask the variation of velocity of p relative to q ne. So expand this, you'll find this is equal to velocity of p relative to earth plus velocity of earth relative to q. So you see here the velocity of p is measured positive. We don't know the direction. Let's say this is the direction. Okay, so for the motion, let's say this is the positive direction. So the object p has 3v or 3u velocity to the same direction, and q's velocity is negative. That means q is moving to the opposite direction with u. So simply, when you substitute the values here, velocity of p relative to earth is, to this direction it is 3u plus velocity of earth relative to q. So q is moving to the left. So when q moves to the left, some observer inside q will observe that earth is coming towards him at the same velocity or the opposite direction. So velocity of earth relative to q, q ඇතුලේ නම් බලන කෙනෙක්ට පේන එක, again to the right, that is u. That means the relative velocity is 4u to this direction. So initially we considered the direction to the right as positive. That means this value also should be a positive value. Positive for u. So the variation it should be positive for u. So you see these two velocities are constant. That means never changes with time. So the relative velocity also does not changes with time, and the value is positive for u. So the answer is the fourth. Okay. Simply. Third question. A person 1 meter away from a sound source hears a sound intensity level of 60 decibel. Then he moves another 9 meter away from the sound source. The new sound intensity level is. So a comparison between two sound intensity levels. So we do comparisons of sound intensity levels using this equation. Beta 1 minus beta 2 is equal to 10 log I1 over I2. So here beta means the intensity level, I means the intensity. So what happened when he moves away? When he moves away, that is affected to the sound intensity. Because we know sound intensity is proportional to, inversely proportional to the distance square. So I can rewrite this side 10 log I1 over I2. So I1 over I2 is R2 over R1 square. First thing, inverse proportion. So if one is in the numerator, in the other side it should be in the denominator. Same way. And this is squared, so there's a square. R2 over R1 square. Okay, then now I have to compare it. So there is the sound source, and the person is 1 meter away initially. Now he moves another 9 meters away. That is altogether at the final position the distance is 10 meters, right? So initially I'm taking 1 as the initial instance. So no, let's consider 1 as the final instance. Okay, so that is the beta is to be found. Let me write like this. So beta minus, I'm taking 2, the instance 2 as the initial instance. So initially the intensity level was measured 60. It is mentioned. So beta minus 60 should be equal to 10 log R2. The final total distance is 10. final total distance is 10, and r1 is the initial distance, that is 1 meter square. Okay, this is initial, this is final. So beta minus 60 is equal to, so when there is a power inside log, you can take it to the front, right? So 20 log 10, log 10 is 1, so beta is equal to 80 oh, sorry, here I just mixed up these two distances. 2 means the initial instance, so it should be 1 here, and here 1 is the initial instance, that should be 10. Okay, now it's fine. So 10 log 10 to the power minus 2 then. So minus 2 come front. So beta minus 60 is equal to minus 20. Beta equal 40 decibel. That is given in the third answer. Okay. That is given in the third answer. Not one. Least count of a vernier caliper is 0.1 millimeter. In this caliper, 20 divisions on the vernier scale coincide with 19 divisions on the main scale. The positions of main scale and the vernier scale of the for a certain measurement is shown in the figure. The reading shown in the figure is okay. So first of all, you have to evaluate the least count. Least count is nothing but 1 minus number of parts on the main scale, that is 19, divided by the coincided vernier scale is 20, times one part of the main scale is 1 millimeter. They have given the discount as well. So sorry, one part. So here you can see one part of the main scale is 2 millimeters. So if you see the scales, here it is 5 and here it is 6. So between 5 and 6, okay, between 5 and 6, so this is measured in centimeters. These values are given in centimeters. So between 5 and 6, there are only 5 parts. So each part should be how much? So altogether this is 10 millimeter. So this should be 2 millimeter. So here it should be 2. So then you can calculate the place count to be 0.1 millimeter. Then the reading should be equal to main scale reading plus number of divisions into least count. So main scale reading, the part just before the zero, the vernier zero is 52, right? So if you see the figure, just before the vernier zero, that is 52nd part, right? So here 5. So this is the, I mean, this is the second part, so this should be 52, this should be 54 actually, 54. And number of coincided vernier parts is what? Here it is given in an arrow. So the vernier part which is in coincided with the main scale part is the 12th part. And the least count is 0.1. So 55.2 millimeters, the final value. It is 5.52 centimeter. So the correct option is the fourth one. Okay. Question. Question. Train passed a stationary observer sounding its horn. Uh, the ratio between the observed frequencies before and after passing the observer is 6 to 5. So if the speed of the sound is in air is 330 meters per second, the speed of train will be. Okay, so here's the observer. Initially the train is coming. So let's say its actual frequency is f0. So the sound wave approaching the observer is something like this. And let's say the observed sound wave is f1. So obviously, if the source approaches, that means the relative velocity inverts. So f1 should be higher than the actual frequency. Clear? And let's consider when the train have passed this observer, an instance. So now the train has passed him. Still, the emitted frequency or the real frequency is f0. Now the sound wave approaches something like this. And let's say the observed frequency is now f2. So now the relative velocity is outwards. That means the observed frequency should be something less than the actual frequency. Okay. In theory, we just talk this. If the relative velocity is inverse, if the observer and the sound source like come closer, then the observed frequency is something higher. If they depart each other, I mean, if they go away from each other, then the observed frequency should be less than the actual. So let's calculate them. F1. So when train approaches, F1 should be equal to the relative velocity with respect to the observer. Observer does not move, that means Vs, okay, relative velocity of sound respect to the observer, divided by relative velocity of sound relative to the source. The source is moving to the same direction of the wave propagation. That means the relative velocity should be something less than the actual sound velocity, Vs minus U, because they are moving to the same direction. Hence F2. F2, if you calculate in the same way, again the observer is stationary, Vs, over source is now moving into the opposite direction. So the relative velocity with respect to the source should be Vs plus U. Well, in that case, the sound velocity propagates to the left, and this is moving to the right. So Vs plus U. Okay, so they have given the ratio. F1 over F2 is equal to 6:5. So just substitute these two formulas. So when you substitute these two formulas here, you will find that F1 F ratio is equal to Vs plus U divided by Vs minus U. So this is equal to 6/5. So now sound velocity is given. So when you know the sound velocity, just the unknown is the velocity of this train. So I'm just cross multiplying and doing the calculation. So 5 into 330 plus 5u is equal to 6 into 330 minus 6u. So 11u is equal to 330 times 6 minus 330 times 5 කියලා කියන්නේ 1 times 330, that is 330. So when you divide both sides by 11, the answer will be 30 meters per second. That is given in the fifth option. Okay. Just remember, the apparent frequency observed by the observer is equal to this relative velocity of sound with respect to let's say relative velocity of sound wave with respect to observer divided by the relative velocity of sound wave with respect to the source times the actual frequency. So this is the formula by which I got those two expressions. Okay. Sixth one. Consider the following statements given about the Jaguar's method that is used to determine the surface tension of a liquid. Okay, the sixth question is based on Jaguar's method. So in Jaguar's method, what we do is we just there is some apparatus like this. And the other end of this tube is submerged in a liquid vessel which contain the liquid of which the surface tension should be measured. Okay, so we need to measure the surface tension of this liquid. So what we do is we will supply some air. Maybe we can blow in air, or maybe we can have some apparatus to done the same function, making a product air. And there is this manometer. So initially the manometer liquid will give the same. I mean, in both limbs there will be the same level of liquid. By the way, when you blow some air, what will happen is there will be a meniscus formed here, and what we do is when the meniscus with maximum pressure difference is formed here, we will measure the difference of manometer heights. So what will happen is when we blow in here from this point, the pressure will increase, right? Because of high pressure, the manometer liquid will be displaced to this direction. So there will be, so using this you can measure the pressure difference, as well as again you need to measure this height, and then with some equation you can just calculate surface tension. Okay, that is what we do in the Jaguar's method. So let's consider these statements. Statement A: can find variation of surface tension of a liquid with temperature. So using Jaguar's method, we can evaluate the variation of surface tension of liquid with the temperature. How? What we need to do is we just need to heat up this liquid vessel into different temperatures. So at different temperatures, you have to measure the surface tension using that theoretical equation. So when you measure those surface tension, I mean, when you calculate the surface tension values using those measurements, you just have to plot those values against the respective temperature. So when you plot them out, you can finally obtain a smooth curve through how the variation of surface tension occurs with the temperature. Usually the variation should be something like this for liquid. Okay, and that's correct there. B: can determine the surface tension of a liquid having different concentrations. That's also possible. So it doesn't matter if you want, you can change the concentration and then conduct the same practical the same way. Then measure the pressure difference using manometer, and then also calculate some pressure difference about this meniscus using the pressure balance of this liquid, and then when you equate them, theoretically you can calculate the surface tension. So the concentration does not matter. And then C: the liquid should be transparent. No, we don't need a transparent liquid, because why? So in Jaguar's method, Jaguar's method, I'm just confusing it with this sports car. Okay, in Jaguar's method, what we look for is the maximum pressure difference. What we are interested is about the maximum pressure difference. So we already know the maximum pressure difference occurs when there is this hemispherical meniscus. So in this theory lesson, we talked about this. When there is the maximum pressure difference, the meniscus is always hemispherical. So we don't need to see it and confirm it, because when there is the maximum pressure difference, it should be the hemispherical one. We don't need to see it, and we don't need to compare it and uh, make sure that it is the hemispherical. It should be theoretically. So we don't need to look at this meniscus. That means it is, I mean, it's fine if this uh, liquid is opaque also. Okay, so it does not need to be transparent. That means this is wrong. So the correct answer is A and B. That is the fourth option. Okay. So seventh. Okay. Charge Q is kept on the center of a spherical cavity of radius r in a block of metal. So block of metal means a conductor material. The electrostatic field intensity of the points A and B is. Okay. So they have marked 2 points A and B. So you can see in the figure that this point A lies inside this metal, I mean, cavity. So it's not on the metal surface, that is inside the cavity. And this B, this point lies in the conductor or the metal block. So we know how to solve this. We discussed this in class. So what happens is conductors cannot have any electric field inside its region. I mean, so in this space there is the conductor. So here this is a conductor material. So within this space there cannot be, it is not possible to have any electric field. So what happens is obviously at point B the electric field should be 0. So how does it happen? How does this conductor material obtain 0 field intensity even if there is a charge in the middle? That is done by inducing an opposite charge in the interior surface of this uh, conductor metal with equal in magnitude to the charge kept inside. So if this is positive Q, then a negative charge is induced in the inner surface of this metal block, so that the total charge inside a Gaussian surface becomes 0. So if this is the Gaussian surface, total charge becomes 0, so no electric flux, so no electric field intensity. Okay, so once this happens, still the total charge on this block should be constant. So initially there was no any charge for the block. So if minus Q induces in the inner surface, to cancel it out, the respective plus Q automatically induces on the outer surface. That is how it keeps its balance. So for point A, if you consider point A, so this is the charge distribution for the region. So if you consider charge A, sorry, point A, if you want to calculate this electric field, you just have to consider the charges which which are positioned inside the Gaussian surface drawn through A. So if you draw a Gaussian surface through point A, only this point charge is there inside it. So the charges inside only matter for the electric field. So it should be 1/4 epsilon Q over A squared. So the respective answer is given in option 4, right? Answer is the fourth option. Answer is the fourth option. We have done similar questions in the class, okay? You have to remember. Question number 8. Work with a pendulum bob consisting a steel wire shows the correct time at temperature of 20 Celsius with a period of 1 second. Okay, this clock shows the correct time with period 1 second with 20 Celsius. Fine. Then, how much time is shown less within 1 hour on a 40 Celsius day? So now the temperature is 40 Celsius. So they are asking how much less time is shown for 1 hour. So how does a pendulum clock measure time? It does measure time by counting the number of cycles. So what happens is it assumes one cycle is 1 second. So it assumes one cycle is 1 second, and then it counts the number of cycles and then measure time. So 1 hour, in actual case, 1 hour should be 600 seconds, that is 3600 cycles, right? Okay, so what happens when it is the temperature is increased to 40 Celsius? Now, obviously, this length will be affected. The time period of a pendulum bob, is affected by the length of the pendulum. So this is affected by the temperature. So the time period also affected. So let's calculate the new time period. So the new time period at 40 Celsius is given by, so we obtained this formula in the class, so I'm not going to prove it again. If the temperature increases, then the new time period should be equal to initial time period times 1 plus alpha delta t divided by 2. So initial time period was 1 plus alpha, the value is given 2 into the power minus 4 times the temperature change is 20. Initially 20 is 40 then, so the change is 20 divided by 2. That is 1.002 seconds. Okay, so what happens? Now, when the temperature is 40 Celsius, the actual time period of this bob is 1.002 Celsius. So if the actual time period is this, how many cycles will this count? So I already told you how this pendulum bob calculate the time is, it will count the number of cycles. For example, in the original temperature, it will count 3600 cycles and then it will say this is 3600 seconds, that is 1 hour. So the same procedure is done at 40 Celsius as well. So how many cycles will this count? So 1 hour means 300, let's say number of cycles. So number of cycles is equal to 3600 divided by 1.002. So this will give you an answer. 3600 divided by 1.002 means 3592.8. So this is the number of cycles it will count. So it will assume each cycle is 1 second. So the measured time will be 3592.8 seconds. So the long time is this. So what is the difference? So the difference in time is to 7.2 seconds. So that is given in the fourth option. Okay, that is given in the fourth option. Okay. Question number 9. The given figure shows the path of a light ray which is refracted through several media of absolute refractive index N1, N2, N3, and N4. At the point X, there is a total internal reflection. So what is the correct relationship among the refractive indices? N1 is the index of air. So this N1 means the refractive index of air. That is one. Okay. So just by looking at the light ray, we can compare this. For example, let's begin with the incident ray. So first, the ray is incident at this point. The ray is incident at this point. So when it is incident, after that point, when it is entering the second medium, the light ray bends towards the normal. Initial path is something like this, so it bends towards the normal. That means this medium should be denser. Dense means higher refractive index. So comparative to N1, N2 should be denser because it is moving into the normal. And then they have clearly mentioned at point X, there's a total internal deflection. At point X, there's a total internal reflection. Total internal reflections only happen when the light ray falls from a denser medium to a air medium. Okay, so when we are telling about this total internal reflection, when we are discussing indicator, I always say total internal reflection always happen when the light ray travels when the light ray tries to travel from a denser medium to rare medium with an angle of incidence which is greater than the critical angle. So obviously, compared to N2, again N3 should be lower. So N3 should be something lower than N2. Okay. Then when it comes to this point, so again you can see the light ray will be incident here like this, and then it again bends into the normal. Here the normal drawn to the surface is this, so it bends towards the normal. That means again compared to N3, N4 should be higher. So compared to N3, N4 should be higher. Then after, we can't say anything about just looking at this, right? Because you see, this is the center of the circle. So when you draw a line from the center of the circle, that become a radius. So this is just, this is a radius of this circle. So the radius is always perpendicular to the tangent drawn. So we can assume the tangent as the interface. So when a light ray falls perpendicular to the interface, it will always follow the same path. So just by looking at this, we can't guarantee anything about N3 and N4, or again in N3 and N1. Okay, these are the things which we can extract from this diagram. So using this, what can we ensure? So N1 means the refractive index of air. So we know compared to air, for any other medium, the refractive index is greater than, for any other medium compared to air, the refractive index should be higher. So the lowest refractive index should be for the air, that is N1, and then N2 should be greater. N2 should be, sorry, then N3 should be greater. So again, greater than that in 2. Okay, so when we compare these three, we can't compare about N4. Sorry, actually we can. By the way, problem is we can't compare about N4 and N3, sorry, N2, because both of these are greater than 3. So we don't know which one comes first, whether it is N4 or N5, N4 or N2. So again, that's not a problem. If you look at this correct order is only given in only one answer, that is the first answer. So we don't know the comparison between N2 and N4. By the way, both should be greater than N3. So the correct order is mentioned only in the first answer. So the answer should be the first. Answer should be the first answer. And the 10th one, rod that is made of a metal of Young's modulus 2 × 10 Newton per meter square is subjected to a strain of 0.06%. So that's a percentage, not the actual strain. So if you want to obtain the actual strain, what you have to do is you have to divide it by 100, because it's a percentage. So the strain energy stored in a unit volume of the rod is, okay, so strain energy per unit volume. So if you remember, when we are talking about this stress versus strain curve, when we talk about this stress versus strain curve, there we got this word, the strain energy per unit volume. Okay, there we told the strain energy per unit volume is given by the area under this curve. Okay. Strain energy per unit volume. Again, this is a theory, is equal to area under sigma versus epsilon curve. So if you try to calculate the area, this is nothing but if the stress is sigma and if the strain is epsilon, then you can just evaluate this area just by half into base, that is epsilon into the perpendicular height, which is sigma. Okay, so we don't know the sigma value actually. The strain is only given. So how to calculate sigma? So within proportional limit, you can apply the Hooke's law, right? Because the Young's modulus is given. So the strain, or whether we can write this equation like this: F over A is equal to Y times E over L. So F over A means this stress. It is equal to Young's modulus, this 2 into 10 to the power 10, and the strain is epsilon. So I'm just applying that here. Half into epsilon into 2 into the power 4. We can just write half into 2 into the power 10 into epsilon square, because there is an epsilon already, and this epsilon, it will be epsilon square. So 2 get cancelled. 10 to the power 10 into epsilon square. Epsilon is 0.06%. So you have to convert this percentage into a fraction. That is done by just dividing it by 100. So when you take the square, here it is 16 to the power minus 2, and with this 2 zeros, it will be 16 to the power minus 4. So altogether, when you do the square, it will be 36 into 10 to the power minus 8. So 3600 joules per meter cube. First answer. First answer. Okay. So just very deep points of theory also matters. Okay. These are like, we don't talk about these earlier in the lesson. These are the like deepest points of the last elasticity lessons. So they also may give you problems in the exam. We have to make sure you know all these things. Okay. Then the 11th. Okay. So the plates P and Q of a capacitor are connected to a direct current, that is DC current, power supply, and a slab of material S is introduced between the plates. The value of quantity Y is found to vary with distance X measured from the plate P is P as shown. Which of the following statements is true? Okay, so they have given the value of quantity Y changes with the distance measured X according to this behavior, what is shown in this graph. So which of the following statements is true? So they are trying to predict about the material of S, whether it is an insulator or a conductor, and then they are trying to predict what is this quantity. So this is something like a special case we study for a capacitor. This thing happens. Okay, this curve, this should be something familiar to you. So this thing happens when you introduce some dielectric material. Okay, when you introduce some dielectric material. Dielectric material means an insulator. Dielectric material is always an insulator. So S should be an insulator. Sorry. I just mixed it up. Yeah, S should be a metal. Okay, right. So that's me. So this S should be a metal. So you see, within this metal, some quantity stays constantly. So what is that quantity? We already talked about for conductors. Conductors always arrange their charges to obtain same potential, right? Conductors always arrange their charges to obtain same potential. So here you see potential does not change. So this should be a metal that is conductor, and then this Y quantity should be the potential. So what happens is when you charge a capacitor, the charges will be formed on both plates, and there will be an electric field formed. So when this electric field is formed, what does this metal conductor does is it will rearrange its charges like this. Minus charges will be induced on this surface, and the positive charges will be induced on this surface. So inside this space, there will be no any electric field, so the potential will stay constant. By the way, at these two areas, there will be an electric field. So because of the electric field, if you remember the theory, to the direction of the electric field, the potential always decreases. To the direction of electric field, the potential always decreases. That's why this minus sign in this equation comes. You see, here there is a minus sign. This minus sign comes because potential decreases with the direction of E. So that is why these two lines are like this. The potential decreases. Okay, so that is about question number 11. Okay. Question number 10. Sorry, 12. Question number 12. So when a capillary tube of radius r is immersed into a liquid whose surface tension T and density ρ, a column of liquid with height h rises through the tube. The angle of contact of this is theta. Taken out the tube vertically and fill same liquid up to a height h. The radius of the meniscus of the lower end of the tube is. Okay. Again, we have discussed the same thing. So So initially, this is one end is sink in the this liquid, so there will be the capillary rise. So let's say this is the height. So if you try to inflate the same liquid height, okay, if you try to entrap the same liquid height without making in contact with some liquid vessel, if you do this, you can see this meniscus formed at the lower end will be a flat, because in this case also this whole weight of this section, okay, the whole weight of this section which comes through the tube is bared by the surface tension forces acting on the upper meniscus. So in this case also, the forces given by the upper meniscus is enough to balance this weight. The forces given by the upper meniscus is enough to balance this weight. So no point of having a meniscus on the in the lower surface. So it will be flat. That means what is the contact angle? What is the radius? They ask me the radius. So flat meniscus means the radius is infinite, right? Because there is no curvature. No curvature means radius is infinite. So the answer is fifth answer. Okay, so 13. Rotating tube of length L and radius R is connected to another tube of length 2R and radius 2R. A steady flow of air is flowing through the tube. The ratio of pressure difference across first tube to that of the second tube would be. Okay, a comparison, right? So for the first one, the length is L, the radius is R. For the second one, the length is 2L, the radius is 2R. Okay, so a pressure difference occurs only for viscous liquid. So for viscous liquid, for the same flow rate, uh, these two tubes are. So just a comparison. So the first tube is connected with the second tube like this. Length is L, radius is R. So for flowing, the flow rate is given by the Poisson's equation, which is Q over T is equal to 5 over 8 e to the power 4 meter delta P over L. Okay. So just find what remains constant and then you can compare the pressure difference. So you see the same liquid flow is there for both tubes. So the flow rate remains constant. 5 over 8 always a constant. Neta, same liquid. So neta is also constant. So the pressure difference, you see, all these terms of this equation is a constant. Then if there is a change in pressure difference, that's because of radius change and the length change. So if you consider the proportion, the delta P, the pressure difference should be proportional to length over radius to the power 4. So you can compare now. Delta P1 over delta P2 is equal to, pressure difference is linearly proportional, directly proportional with length. So the length ratio in the same way. So initially the length is L, finally for the times delta P is inverse proportional to the radius. That means the opposite way. So for delta P1, the radius should be in the denominator, that is R. For the delta P2, the appropriate radius should be on the numerator, that is 2R to the power 4. So L get cancelled, RR get cancelled. This is 16 divided by 2 is 8. So the ratio should be 8, that is given in the first option. Again an easy one. In the 14th. Okay. A cylinder contains a mass of air enclosed by a light, smooth piston. The atmospheric pressure is 100 to the power 5 Pascal. When the piston is free, the length of the air column is 10 centimeter at temperature 27 Celsius. So there is this vessel, and the air inside this vessel is held using a piston. Initially, it is free. So when the piston is free, the length of the air column is 10, and the temperature is 27 Celsius. By the way, when you are applying gas laws, this is a question related with gas laws. So when we are applying gas laws, we consider the Kelvin temperature, that is 300 Kelvin for 27 Celsius. So when the piston is moved down, uh, so when the piston is moved down by 8 centimeter, the pressure inside the cylinder is 16 to the power 5. Okay. What is the new temperature inside the cylinder? Okay. So let me. So there is a mistake about this question. In this question, this should be changed when the piston is moved until the air column length is 8 centimeters. That should be, so this 8 centimeter should be the length of air column. Okay, so that's what I look for. This should be length of air column. That does not mean the piston is moved by 8 centimeters. Okay, now it's fine. So when it is moved until 8 centimeter, that is, this is 8 centimeter, pressure inside will be 16 to the power 5. So initially the pressure was 1 to the power 5. Now the pressure changes to 16 to the power 5. So what is the new temperature inside the uh, this cylinder? What is this? So that's what they ask for. Okay, so the basic gas law is this: PV equal in RT. For any gas, you can apply this if it is ideal. So you can see that this air is restricted to move out from the cylinder by this piston. So inside this inside this cylinder, the mass of this gas should be constantly, that should be constant. It can't change altogether. So PV over T ratio for the gas should be constant for both cases. So for the initial state as well as for the final state, pressure times volume divided by the temperature constant. This should be a constant for both um, instances. So initially the pressure is 105. Initially, what was the volume? So if you consider the cross section area as A, initial volume is nothing but A into 10, right? The units does not matter. Okay, we are just comparing two sides. So if you apply in the same units, that's fine. By the way, not for the temperature. Temperature should always be in the Kelvin. So initially the temperature is 300. Okay, see ratio for the initial state instance, and then for the final instance, the pressure builds up for 16 to the power 5. Finally, the volume is A into 8, and this is the new temperature. Okay, so just solve this up. You will find that the new temperature is 16 into 8 into 3. Okay, so if you solve this should be equal to 3840 Kelvin, by the way. This is Kelvin. So when students get this answer, they will be quick to go for the second answer, but it is wrong because in the answers the temperature is given in the Celsius thing. So you have to subtract 273 because you need to make it to Celsius. So 3, 5, here it will, so 7, it will be 13 minus 6 means 1 means 6. So this is the answer in Celsius, which is given in the third option. So don't do that mistake. Once you get this value, don't just go for the second answer because that value is in the Kelvin. Okay. 15th. When a tuning fork and acoustic wire vibrates with length of the wire is 95 centimeter and 100 centimeter, beats can heard with frequency of 4 hertz. So what is the frequency of the tuning fork? Okay, so okay. So there's a tuning fork. Let's say the frequency is F. So when it vibrates with one wire, the length is given 95 centimeter. It will give you beats of 4 hertz. And again, if you vibrate with another wire with different length, that is 100 centimeter, again it will give you a beat frequency of 4 hertz. So they're asking, what is the frequency of this fork? And for this question, I think you have to assume the sound velocity. So let's try how to do the question. So let's say the sound velocity of the medium is v. This will be finally cancelled out. Okay. So if you compare these two cases, here you can see the resonant length is lower. So if you remember the theory, resonant length and the frequency are two different, like two inverse cases. So lower resonant length means higher frequency. So in this case, if there are beats, then this frequency should be higher compared to this one. So with the higher frequency, if this tuning fork gives you 4 hertz beats, then this should be so if I assume the frequency of this tuning fork as f, then obviously the frequency as the first case, let's say f1, it should be higher. So f1 minus f should be 4 here, because if you compare these two cases, I mean, beats can occur. The beat frequency is just the difference between two frequencies. So it does matter the order. So in these two cases, both will give you 4 hertz beat frequency. By the way, the same. So for the first case, f1 should be higher. F1 should be higher means it should be higher than the tuning fork. And this f2 being lower, means it is lower than the tuning fork. So this should be f minus f2. Okay. So I can just build up an equation for the uh, uh, for this f1 and f2 using equal f lambda. How? So for the standing f equal f lambda, then the velocity is v. The frequency f1 should be f1 times here the lambda. So if I take lambda is lambda 1, is one loop. So lambda 1 over 2, length of a loop is equal to lambda 1 over 2 into 1 should be equal to L1, that is let's say L1, that is 95 centimeter. So L1 is equal to lambda 1 is equal to L1, like this. So F1 I can just write V over 2L1. The same way I can obtain an equation for F2 as well. So F2 is equal to V divided by 2L2. So I'm just applying for the first and second equations. So from the first one, I get F1 is V over 2 minus F is equal to 4. Okay, let's keep it like that. Or maybe we can rearrange like this. V over 2L1 is equal to F plus 4. Let's say this. From this equation, f minus f2. F2 is the frequency of the second string, that is V over 2L2. It is equal to, again, 4. So again, I'm just subjecting V over 2L2 term, that is equal to f minus 4. Let me say this is the fourth equation. When you divide these two equations, V get cancelled. So you don't have to worry about V. And when you divide it, this L is in the denominator. That means divide the 3 by 4, it will be L2 over L1 is equal to f plus 4 over f minus 4. Okay, now you know these values. L2 is nothing but 100. L1 is nothing but 95. So it is equal to f plus 4 over f minus 4. So just now you can rearrange this equation and solve for f. So I'm not going to solve for f. So if you solve this, you will find this f is equal to 156 hertz. That's a good question. Okay. So this question paper 4 is somewhat better than the previous papers actually. This contains a good level of questions. මම කියන්න මේ මෙතන දැන් දෙකේම beat frequency එක 4යි කියන්නේ beat frequency එක 4 වෙනකොට ඔකට වැදගත් වෙන්නේ beat frequency order එකනේ. අපි හැම වෙලේම beat frequency එක හොයන්නේ frequencies දෙකක වෙනසකින්. ඒකේ matter වෙනවා කාගෙන්ද කවුද අඩු කරන්නේ කියන එක. ඒක choose කරගන්නේ මේ lens බලලා. මෙතන length එක අඩුයි කියලා කියන්නේ අනිවාර්යෙන් මේකේ frequency එක වැඩි වෙනවා. මොකද resonant length එකයි frequency එක අතර inverse proportion එකක් නේ. So lower the length means higher the frequency. So මේ cases දෙකේදීම 4 එනවා කියලා කියන්නේ එකකදී fork එක වැඩි වෙන්න ඕනේ අනිත් එකේදී fork එක අඩු වෙන්න ඕනේ කියන්නේ order එක මාරු වෙනවා. frequency එක වැඩි. මෙයාගෙන් තමයි fork එකේ frequency අඩු වෙන්න ඕනේ එතන. f1 minus fork එකේ frequency කියලා තමයි මේක එන්නේ. මෙතනදී length එක වැඩි හින්දා frequency එක අඩුයි. frequency අඩුයි කියලා කියන්නේ compared to this fork it should be lower. So when you are subtracting it should be f minus f1. Then you can rewrite these equations and come to the final answer. Okay, 16th. An object of mass m is projected with an initial velocity v at an angle of inclination theta. The horizontal ranges are the angular momentum of the angular momentum about the point of projection when the object is at the maximum height is. So there is a projected object. So they have given the range is capital R, and they have specified again this maximum height is in the answers they haven't given it. So they have given the velocity as well as angle of projection. Those things are only things which are given. So they are asking to calculate the angular momentum of this object when it is at the maximum height. So when it is at the maximum height, you know the velocity is only acting in the horizontal direction because the vertical component almost becomes zero. Already becomes zero. And again, you know, this horizontal component is nothing but v cos theta. The horizontal component never changes for the whole motion. It's v cos theta. Okay, so how to calculate this angular momentum? So they are asking to calculate the angular momentum compared to the axis drawn from the point of projection, that is this point. If it is O, if I take the maximum h max, I can find the angular momentum. How? Angular momentum I omega, right? Moment of inertia into omega. Again, we can rearrange this for a point mass. For a point mass like this, the inertia is given by mr squared, and omega is nothing but velocity divided by r, tangential velocity divided by the radius, isn't it? So when you apply this here, you will get the angular momentum. Another way to calculate the angular momentum is by mrv. So if you remember this formula, just directly apply it. Okay, you don't need to again solve and get the formula when you're doing the MCQ. If you remember it, you can just apply it. So here m is the mass, r means the radius, that is the maximum height here. Okay, the radius to the object, and v is the velocity. Okay, so when I apply the appropriate constant, m is the same thing. R means the radius, that is the maximum height. Okay. When this object is at this point, the radius you can assume the perpendicular distance, that is the maximum height. And the velocity v cos theta, basically. So what is the maximum height? The problem is they haven't given h max in answers, so you have to replace it in terms of r, by the way, because in answers there is r. So let's try to do it. So if you remember the projectile theory, okay, just let me try it from the beginning. So I'm just writing an equation for the maximum height. When you consider the vertical motion at the maximum height, vertical velocity is 0, initially v sine theta gh. So h max, if you subject it, h max is equal to v squared sine squared theta over v. Okay. Again, if you consider horizontal range, again, I'm not going to show this up, by the way, because we have left. Right? The horizontal range is given by v squared over 2g uh, 2v squared over g theta cos theta. Okay, this is the equation for the horizontal range, if you remember. So let's try dividing these two. Then I may obtain a formula for H max in terms of R. So if I divide these two, H max over R, I get this V squared over G term get cancelled. Sin squared over 2 will be there on the denominator, and here it will be 2 sin theta cos theta over 1. Okay, V squared over G is there for the both expressions. So when you divide them, V squared over G will be cancelled. All the other terms will be there. Now again I can cancel. There is a sign, and the denominator also there is a sign. So I get H max. H max is equal to R over 4 sin theta over cos theta. R over 4 sin theta over cos theta. Okay, now I can apply this value for the formula which I obtained earlier. That is this. If I take this formula as let's say A. So from A, now I can solve this up. M times H max is R over 4 sin theta over cos theta times V cos theta. So cos theta term get cancelled. MRV sin theta over 4 or MVR sin theta over 4, that is given in the fourth answer again. So again, that is a good question. So these days there's a lot of going with cricket, right? Okay. So for Sri Lanka, there's a different situation. So what they are now doing is they are just blaming the ground because they lost. Blaming the ground and the crowd. They are blaming all the external factors. So don't be like Sri Lankan cricket team. Will be always there. Will be people looking at you, your work. So they will always look at you, even if you win or lose. Does not matter. They will be looking at you, and maybe they will laugh at you. But still, what you have to know is you have to do yourself. I mean, you have to perform your work regardless of their. I mean, uh, whether they laugh at you or whether they uh, appreciate you. You have to perform your work. So for A levels also, it does not matter how the other people react to you. You have to do your work yourself. That's the only thing. So finally, when the results come, all the things will be positive, by the way. But even if the things are negative, you have to continue. You can't blame like Shanaka. Yeah. 17th. A certain person can see objects clearly only when they were in between 0.5 meter and size. Okay. To see distance objects clearly, which of the following lenses are most suitable for him? there's a person, he had both sightedness, and he can't see, uh, his eyes having a lot of issues. He can't see either the short distances, also either he can see the large distances as well. So only 0.5. And so now what he want to see distance objects. Distant objects, we assume the far point is infinity, and the healthier far point, or the normal far point, we assume is at the infinity. So now he want to see objects at infinity. By the way, for his eye, the far point is at 2 meters. So if he uses a lens, what that lens, then that lens should be equal to, that lens should be able to form images of objects which are at infinity. So when the lens rays from infinity, this lens should be able to put them, I mean, pass them to the other side, such that the rays are just coming from the far point of this faulty eye. This lens corrects the vision. Then the purpose of this lens is to put the light rays coming from the infinity, such that after they will come from the far point of this person. හරිද? يعني මිනිහාගේ far point එකේ එන විදිහට පෙන්වන එක තමයි lens එකේ වැඩේ. So obviously this lens should be a concave lens, right? This is diverging. And the focal length, again, it directly come from the definition. So parallel rays diverge from the focus. That means the focal length should be equal to 2 meters. So concave lens with focal length 2 meters, that is given in the fourth answer. Question 18. The figure shows PV diagram of ideal gas when going from point A to B. If 200 joule heat supplied to the system, the internal energy of the gas. So in the answers, they expect whether if it is decreases or increase, and the value. Okay, this is to be solved with first law of thermodynamics. That is, the amount of heat supplied to the system is equal to the change in change in internal energy, or maybe you can say increase in internal energy plus the work done by the system. Okay. So what is the heat given? 200 joules of heat is supplied. That means amount of delta Q, the amount of heat supplied, is equal to plus 200 because it is supplied. And the change in internal, that is what plus the work done by the system. Remember, in thermodynamics, the work done is positive only when the volume increases. If the volume increases for the system, then we say the work done is positive. If the volume decreases, then the work done is negative. Okay. If the volume decreases, the work done is negative. So in this, what happens when it is transferring from state A to B? Obviously, the volume decreases. So the work done should be negative here. It should be something negative. And how to calculate the value? So when you have the PV diagram, the work done is nothing but the area under the, or else you can just calculate the work done by P delta V. Maybe you can employ this form also. So otherwise you can just calculate the area. So when you calculate the area, it is the pressure is 50, and the change of the other dimension is uh, 10 minus 4, that is 6. So delta U comes plus 500 joules. So delta U is positive, means the internal energy increases, because in the definition the amount of heat supplied is equal to the increase in internal energy plus the work. So if the value is positive, then there is an increase in internal energy. That means the answer is the first. Okay. Okay. The figure shows water flowing at a constant velocity through a horizontal tube complex. The graph shows the exact variation of kinetic energy per unit volume of water along the axis of the tube with time t. Okay. Kinetic energy per unit volume. You should be familiar with this. Kinetic energy per unit volume. That is the kinetic energy divided by volume. We met this quantity in the Bernoulli's equation. You remember half rho v squared. So for all this term, we call this is the kinetic energy per unit volume. Okay, so if we want to compare the kinetic energy per unit volume, so on what factors that is affect the kinetic energy per unit volume is affected by the density of the water, and we know in the uh, within A-level syllabus we consider only incompressible cases. That is, density never changes, so we don't need to worry about density. So if the internal kinetic energy changes, that means that is because of the velocity. So if we obtain the variation of velocity, then we will be able to take the appropriate graph of variation of the internal kinetic energy with the distance. So A, B, C, D points are marked here. A is here, and C somewhere here, and then comes D, finally E. And point E comes. So how to compare the velocity? So if the flow is steady, when the cross sections are given, we can compare the velocity just by using the continuity equation. We don't need to go for any other equation. If you are provided with the cross sections, you always compare the velocity using the continuity equation. That is, A1 V1 is equal to A2 V2. This is how you compare the velocity. So this means just the product of cross section and the velocity stays constant. A1 V1 is equal to A2 V2 means at 2 points this product is equally. So we can assume cross section times the velocity for any point should be constant. That means the velocity should be inverse proportional to the area. So here in this section, if you consider the area, so this is the flow. Flow is acting along this line. If we assume the flow is acting along this line, the area should be considered perpendicular to it. That means this area. So initially the area is lower. Lower area means higher velocity. Higher velocity means higher kinetic energy per unit volume. And again, if you consider the whole region from A to B, the whole region from A to B, the cross section never changes. It stays constant. So cross section stays constant means the velocity also never changes. So the velocity is obviously higher, but the value never changes. Value never changes means the kinetic energy also will be higher. By the way, the value never changes until B. So after B, you can see the cross section suddenly increases. Higher cross section means lower velocity. Again, lower velocity means lower kinetic energy per unit volume. Again, until point C, the cross section never changes. Until point C, the cross section never changes. So the velocity, the lower velocity never changes. So until Z, the lower velocity never changes. And again, after C, until D, again what happened? The same cross section is maintained, right? The same cross section is there. The same cross section is there. So if the cross section is same, the same variation should be until point D. And after D, what will happen? After D, the cross section will be lower. Lower cross section means higher velocity. Higher velocity means higher kinetic energy per unit volume. Again, if you compare the region between AB and region between D and E, so in both cases, if you compare the cross section for the naked eye, it is a kind of equal, right? These cross sections are kind of equal. So equal cross sections means equal velocities. Equal cross sections means equal velocities. So equal velocities means again equal kinetic energies. So obviously this should be high and higher, high as the value was which was in the section AB. So the appropriate variation is given in the second option. See how questions from different parts of the syllabus comes all together in the paper. So this is what you need to practice. Okay. So why a certain country tries to hold the World Cup in their own grounds? A certain team tries to hold the World Cup in their own grounds because they are their grounds. So they are familiar playing there. If these are their grounds, then they should be familiar playing at those grounds. So the same thing works for the A levels as well. So if you practice the question structures in A level papers, whether it is MCQ, whether it is structured essay, or even for essays. So any case, if you practice the same kind of questions day by day for a long time, so they will be your own grounds. So why can't you play there? You can just go and play. So that is the advantage of uh, doing question papers, right? I mean, you don't need to join you don't always need to join a paper class. Whether if you do the questions by yourself, that's again enough. So the paper class is needed if you want assistance. Okay. So that's why I normally don't ask my students like compulsory. I mean, so if there is no any special case, I don't ask my students to join these discussion sessions, wasting their time. What they ask is if you have any thing to be clarified, maybe even after the session you can watch this and cover those things. Else, no point of uh, wasting your time joining this session unless you want to go through most of the paper. So if most of the paper is a question for you, then you definitely need to follow the session. Okay. So that is the case. By the way, the Sri Lankan people, I mean, don't be like the Sri Lankan team, okay? They just can't play in their own grounds as well. That normally happens, does not happen. So see India. So how the India behaves these days. They have lost for South Africa, but in other matches, how the Indian cricket team bats in their own grounds. So just see that. Yeah. So 20th. Consider the simple harmonic motion of simple M that occurs after it is pulled slightly below the equilibrium position. The mass of each spring is negligible and the spring constant of the spring is k. The fourth statement regarding the motion is first one, the acceleration of the object is proportional to the displacement. Okay, so basically, so when you release this system to move, it will be a simple harmonic motion because you can there's a system of springs. So even if it has a system of spring, you can consider a single spring which will give the same result. So when you consider that equivalent spring, so this is just some mass held by a spring. So we already know this will move in a simple harmonic motion. So in a simple harmonic motion, obviously the acceleration is proportional to the displacement. Okay, that is the characteristic equation for a simple harmonic motion. That's correct. Okay. First one is correct. There should be a negative sign. By the way, this is proportional. Acceleration is always directed towards the equilibrium point. Again, that's also correct. So when this is in equilibrium, let's say this is the equilibrium motion. So the simple harmonic motion always occurs keeping the equilibrium level uh, as the symmetric axis for the motion. So this object will move to both sides in the same behavior periodically, like this. Okay? So it's symmetric over the equilibrium point, and the acceleration always acts towards this equilibrium level. So whether this object is uh, upper to the upper to this uh, equilibrium level or lower to the equilibrium level, it doesn't matter. In both these cases, in all these cases, the acceleration always lies towards the equilibrium point. That's again correct. Third one, the period of this spring is 2 phi square root 2m over 3k. So we will see whether it is correct. So how to obtain the time period? Time period is given by 2 phi square root m over. So when there is system of springs, you have to consider the equivalent spring constant. So for this spring, you have to consider the equivalent constant. So how to get the equivalent constant? So for a single spring, it is k. So these two springs are parallel. Parallel means the spring constant get added. Okay? The equivalent constant is given by the sum. So kk means 2k. So you can consider the system a 2k spring here and a k spring just below it. These two are in series. So for a series connection, the equivalent spring constant is given 1 over 2k plus 1 over k. So 1 over the equivalent constant is equal to 1 over one constant plus 1 over the other constant. So equivalent constant you can calculate. So when you get for the same denominator, this will become 2. So this is again become 2. 2 plus 1 is 3. So 2k over 3. So when you apply it here, this equation will become 2k over 3m. Okay. You write 3 here, then the 3 will go to the numerator. So this will be the time period. By the way, in the answer, these two values are interchanged. So this is wrong. So the false statement is the third one actually. So if I read through the 5 and 5th, in the 5th one, the above system is in a vacuum, the amplitude is constant. Yes. So if the system is in a vacuum, if the system is in a vacuum, then there is no way to lose its energy. So if it does not lose an energy, then the motion should continue the same way. That means the amplitude stays constant. So that's correct. The maximum kinetic energy of the equilibrium position of the maximum kinetic energy, it should be is at the equilibrium position of the object. So let me change it. It's also correct. So the maximum kinetic energy is at the equilibrium position. That's theory. And then the 21st. And first is also a good question. This whole paper is a good paper. I mean, it's always a good paper, right? When you do a new paper, it always become a good paper. That is physics. Okay, so 200 ml from each of water and oil are contained in two identical calorimeters, and they are hung in the surrounding for cooling. Okay. The heat absorbed and or released by the calorimeter is equal to the heat absorbed by 100 gram of water. Okay. So they have mentioned that the heat absorbed or released by calorimeter. Okay. So if you do the calculation for the calorimeter, you can assume calorimeter as 100 gram of water. So just you can do the heat calculations assuming the calorimeter as 100 gram of water. The cooling curves relevant to two systems are given in the figure. The density of oil and water are 800 and 1000 kilogram per cubic meter respectively. The specific heat capacity of water is given. The specific heat capacity of oil is okay. So the cooling curves are given for the same temperature range. So you can see for the same temperature range from theta 1 to theta 2, the cooling curves are given. Okay. So if it's the same temperature range, so this is the cooling by convection. So there is a law for convection which is called the Newton's cooling law. There they say the rate of heat flow is proportional to the excess temperature when all the other parameters are constant. So here this theta means the temperature of this liquid and theta naught is the atmospheric temperature. Okay. So when the same temperature range is considered for both liquids, when the same temperature range is considered, you can assume this stays constant. So this is actually what is done in the practical as well. There is a practical which is based on Newton's cooling law. So there also we consider the same interval. I mean, there are two ways. So in one way, they consider the time taken to lower the temperature by the same amount for both curves. So when you consider the same temperature range, the rate of heat loss for both cases should be equal because rate of heat loss only depend on the external, I mean, the excess temperature. So rate of heat loss for water should be equal to the rate of heat loss for oil. So water, how do you find? So when I mean water, it's not only water, okay? There's the calorimeter as well. So you have to consider both water and calorimeter, okay? Again, if I mean oil, then again oil and the calorimeter. Okay. So for water, I can do the calculation. So Q is equal to mc delta theta when there is a temperature range. Then you can divide both sides by time. So when you divide by time, you can divide it here because we can find times using this curve. So the rate of heat loss of water should be equal to the mc of water, that means mass of water, Cw of water, plus for the calorimeter also we can do the calculation. So the calorimeter initially said the calorimeter can be assumed as 100 grams of water. So mass of water, I mean, when you consider the calorimeter, the heat capacity can be calculated. Mass is zero point 0.1 of water times heat capacity Cw, same of water. Clear? Times uh, great, I mean, delta theta over T, temperature change divided by time. So in both cases, temperature is changed by the same amount. So let me write delta theta. What is the time taken? So when you see the curve for water, this is the curve for water. So the time taken to cool from theta 1 to theta 2 is this value. So when you read that value, that is 2 minutes, right? 4 minus 2, that is 2. Should be equal to the rate of heat loss by oil, that is again equal to mass of oil times the capacity of oil, plus again there's the calorimeter. So calorimeter again can be assumed as 100 grams of water. 100 means 0.1 kilogram. So the heat capacity, what is the heat capacity? That is um, zero point 0.1 times the specific heat capacity of water, right? So just like I did was, when I mean this thing, or when I mean this thing, the heat released by water is not only released by oil, is not only the heat released by oil, but also you have to consider the calorimeter as well. So that's why there are two components coming. So this thing comes from this thing, and here from this part, the second section comes. Okay? And the same temperature range, what is the time? Time is now to cool from here to here. The time is, if you see the curve, 2 minus 1, that is 1. Okay, now the things will be cancelled and substitute the values. Again, the masses are not given. Masses are not mentioned. So when you don't have masses, how to calculate masses? Again, the calculation will be complex. So the mass of water can be calculated considering the volume. So volume of water times the density of water. Density of water is given. So 200 into 10 to the power minus 6, because it is ml, you have to make it meter cube. Then density is 1000 watt. So the same way, mass of oil also can be calculated. 200 into the power minus 6, the same volume, and the density is 800, right? So take the values NW and MOL and substitute the values here, and the only unknown in this equation is this thing, C oil. So you can find it, and finally if you solve this, you should be able to get the answer. C oil, I'm not just solving this now, 12.5 joules per kilogram per Kelvin. This Newton's law of cooling we have to in the class. We didn't still talk about this in the class. So the next day actually we have to finish this off. Convection law. 90 seconds. Person traveling in car is holding a cylindrical cup of tea vertically as shown in the figure. Neglecting the vibration of the car, the maximum acceleration of that maximum acceleration that the car can go without spilling anything. So just neglect the vibrations. So if this car accelerates horizontally, then this beaker also accelerates. So when the beaker accelerates, what happens is the initial horizontal free surface, this free surface will be rearranged. Okay. So if the acceleration is to the right, the free surface will be something like this. So at the maximum acceleration, what should happen? At the maximum acceleration, without the spilling, this surface should be something like this. So it's now going to just about to spill. See, it is now just about to spill from this side. So if the acceleration is increased further, then it will try to like rearrange like this, then T will be spilling. Clear? So at the maximum acceleration, the surface should be something like this. So this horizontal level is this, and compared to this horizontal level, this is 1 centimeter. So 1 centimeter going up means 1 centimeter should go down as well because the same volume. So the volume comes here should be released from somewhere else. So this volume is the volume of water which is released from these points here. So 1 centimeter up means 1 centimeter down from the other side. Okay, so how to connect it with the acceleration? Okay, so if this angle is theta, yeah, so let's try to connect this with acceleration. So what we normally do is we just consider a point or a fluid particle on the free surface. So when you consider a point particle on the free surface, if this inclination is theta, there will be a perpendicular reaction like this, perpendicular to the surface, and there will be the weight. So if this is theta, this will become 90 minus theta, that means this is theta. So if you consider the horizontal movement, the required unbalanced force is provided by r sine theta. So r sine theta should be equal to ma if the mass is m, and r cos theta should balance the weight. So when you divide these two, you can interrelate the angle and the acceleration. How? Sine theta over cos theta becomes equal to a over g. So acceleration is nothing but g tan theta. Here sine theta over cos theta means tan theta. Okay, so at the maximum acceleration, then theta should be maximum. So what is maximum theta here? Maximum theta is this, the one I have drawn in this diagram. So tan theta tan value, what is the tan value? So this is 1 centimeter. So if you consider this right angle triangle, tan theta max should be equal to 2 centimeter divided by this horizontal length is 3, 2 over 3, 2 over 3. So you can rearrange like this, right? This 2 can be taken to the denominator, so it will become 3 over 2. So 3 over 2 means 1.5. So the answer is 30. Answer is 30. 23rd. Okay, that's a simple one. In 23rd question, there's a YouTube and three different liquids are there. So which of the following equations will correct relation between the densities? They asking the correct relation between the densities. So you just compare the pressure balance. Okay, you just have to compare the pressure balance, but you have to consider the pressure balance for the same liquid. So if this is the medium, you should consider the pressure balance for the same liquid. So if you compare a level, both sides at that level should be the same liquid. So you can compare the pressure balance at the interface, which is between rho and rho 2, rho 1 and rho 2. So when you compare that level, so if you uh, extend the level, you can see downside that will be the same liquid. So we know the pressure at the same level will be same for the same liquid. And the liquid level pressure is equal. So when you do that, you will find that 15 into, H rho g, I'm applying H rho g. So the pressure building from this side, 15 into rho 1 is equal to the pressure building from the other side, that is 10 into rho 3 plus 5 into rho 1. So just 3 rho 1 is equal to 2 rho 3 plus rho 1. So yeah, rho 2. So the answer is straightforward. The first one. That is very easy one. 24th. 24th. Okay, so the Q1 and Q2 point charges are kept 6 meters away from each other at A and B points. The plus Q charge, which is at C, is taken from C to D along the circular path of radius 8 cm as shown in the figure. Which of the following expressions give the change in potential energy of the system? Okay, so this plus Q charge is changed from C to D along this circular path. So what is the change of potential energy? They ask the change of potential energy, right? Delta of EP. So which component cause the change in potential energy? The change in potential energy comes due to the change of position of this plus Q. So plus Q builds up potential energies with the charge Q1 at A as well as the charge Q2 at B. So initially there were some the potential energies. So finally, when it comes to this position, the potential energies will be changed now. So how can you calculate the change? So these lengths, let me mark. So length between these two is 6, and this should be 2, right? Because this is moving along a circle. So if this is 8, then the same radius should be here. So altogether it should be 8. So if this is 6, this should be 2. Okay, so change can be evaluated by comparing the initial or we can compare the final position and the initial position. So I'm just subtracting the initial kinetic energy from the final potential energy. So what is the final potential energy? So at this point, the final potential energy I can write 1045 epsilon. So remember the potential energy is given by electric fields 1045 epsilon Q1 Q2 over R. R means the distance between the charges. Here, if you consider these two, Q1 over the distance is 8. And if you consider these two, final one is Q2 over 6. But you have to consider the potential energy of the system. So when you consider the system, the total potential energy is built up between these two, as well as between these two. So these two, the potential energy is Q1, Q2 over 6. So this is the initial minus final 1045 epsilon. Sorry, this is the final. So what is the initial? So initially this Q was here. So at this point, between these two, Q1 over 8 plus between these two, what is the potential energy? So this is 8 and this is 6. So this should be 10, right? This is a right angle triangle. So 6, 8 means this should be 10. That is just the Pythagoras theorem. So Q2 over 10. So between these two, as well as between these two, again, the same thing comes Q1, Q2 over 6. So this is for these two charges. So you see, in the initial one, sorry, in the final one, as well as initial one, this Q1, Q2 over 6 is there. So when you subtract these two compounds will be cancelled. Again, 1045 epsilon. When you take uh, yes, initially this should be 2. So between Q2 and Q, the distance is 2, so this should be 2. Okay, right now. All right. So Q1 over 8 is there again in both cases. So these two also getting cancelled. Now I can take out we can keep it like that. So Q2 over 2 minus Q2 over 10. So this is given in third answer. This is given in the third answer. So 24th, third answer is. Yeah. 25th. Again, a good one. A uniform rod. The uniform rod AB of weight W is placed against a vertical wall with the aid of a string, a light string tied to the rod at 3/4 of its initial length from A. Okay, so there is a string to which this rod is connected, and this is kept uh, perpendicular to this vertical wall, holding by this tension as well as the friction. So this length is 3/4 of the total length. So the reaction acting on the rod at A is. So they ask me to calculate the reaction at this point. Okay. So how to evaluate the reaction? So we will mark all the forces here. First of all, there's the gravity. Gravitational force should be there. I'm just extending the line of action. Then after, what is the force? This is connected using, I mean, there's the tension of this spring. So the tension is there. So there are two forces. And if you consider the whole force, the whole reaction force at this point as a single reaction, so if you consider this is a single reaction, how many forces acting on this product? Tension, this weight, and reaction. Three forces. So if there are three forces, then those three forces should be, the lines of action should be passing through the same point. That means the reaction should be something inclined. The inclined reaction means what? In physics, we don't need normally use the questions using geometry. We can consider this inclined reaction as sum of x component and y component. Basically, this x component is the perpendicular reaction. That is the reaction that we know, perpendicular reaction. How this y comes? Y comes because of the friction. Okay, a parallel component along this wall comes because of the friction. So if there was no any friction, then we can't keep this system like this. The friction should be there. Okay. Anyway, so to calculate the reaction, we have to find this x and y value separately. So how we can do that? How we can do that? First of all, let me find the tension. So if this angle is theta, it should be theta. So the tension T here, I can calculate considering moment. So if the system is in equilibrium, if the system is in equilibrium, the moment should be zero. So W into 3L over 4, that's the moment made by the weight, should be equal to the moment by the tension. So if you calculate the perpendicular, sorry, this is not 3L over 4. The weight acts at the midpoint. Midpoint means this is L over 2. Then this length is the 3L over. So the moment by the tension, you can calculate T cos theta, that is the perpendicular component into the distance, that is 3L over 4. Can get cancelled. You may find the tension is equal to, here this will be 2W over 3 cos theta. And that is the tension. So you can calculate the x component and y component separately. So when you consider the equilibrium, and if you write the equation for the forces along horizontal direction, they should be balanced. Okay, at the equilibrium point, the forces along the horizontal direction should be balanced. That means x should be equal to, the x reaction should be equal to t sine theta, right? That is the only reaction. That is the only other component of component in the horizontal direction other than this x. In x සමතරව තව horizontal force එකනේ මෙතනින් විතරයිනේ. So t sine theta. So t is, we already saw that t is equal to this 2w over 3 cos theta, and I just wrote cos theta under sin theta because then there is a separate meaning, that is tan theta. So x component is 2w over 3 tan theta, and if you consider the y component, so consider the vertical equilibrium. So vertically, how many forces? This y component is there, and there's a component coming from the tension as well as the weight. So t cos theta plus is equal to w. So y is equal to, what is t cos theta? So here, if you see at this point, if you multiply this cos theta to the other side, then t cos theta is equal to 2w over 3, right? So let me 2w over 3 plus y is equal to w. So y is equal to w over 3. Okay. So now you know x component, y component separately. So the reaction, so you can expect this kind of, this level of a question as a 75 mark question in combined maths paper, like this one. And when means you may get 15 minutes to solve this, and you separately learn theories. So RIP by ourselves. So that's why I told like this paper is kind of hard compared to the previous papers. MCQ is hard. I'm not. Essay is not that hard as I remember. So when you take this square and when you take the square root, you can take w over 3 square out. So there is a w over 3 here, as well as here also there is a w over 3 square. So when you take that out of this square root, it will be w over 3 only, and this will be 1, and here there will be 2 square. 2 squared is 4, 4 tan squared theta. So this answer is given in the fourth option, w over 3, 4 tan squared theta. 96. Figure shows a floating cup in a container of liquid, and two objects A and B are floating in that liquid container. Okay, accurately indicate the relationship of H1, H2, and H3 and H4. So this is something like this. There's a big vessel and there's a liquid inside the big vessel, and they will keep another vessel on top of this. So what happens is the upthrust force will be equal to the weight of the second vessel, and it will float freely on the liquid. So this is the first approach. This is the initial condition, and then they will keep some masses. This is how it looks before keeping masses. That is given in the first one. That is the level H1. And in B, both masses are placed on the inner vessel. That means what should happen? If two masses are there, then I mean, so initially the liquid was displaced. Or so here, when you consider the equilibrium of this inner vessel, this liquid was displaced just to balance its own weight. The upthrust uh, exerted on this displaced liquid volume is enough to balance its own weight. So when two other masses are added up, then it should displace more liquid, right? It should displace some more liquid. That means it should go down. Going down means the liquid here should go somewhere else. That means the liquid level should be increased. So compared to the first case, when both masses are kept inside, the water level at the second case should be higher. So H2 should be higher than H1, obviously. And uh, when you compare 2 and 3, okay, when you compare 2 and 3, what is the difference? In 2, both objects are floating. I mean, and enough liquid volume was displaced. But in third one, you can clearly see that this object A is fully immersed. Then just rest in the bottom of this outer vessel. That means this is a denser material. This is a denser material. So it does not now, I mean, in this case, this does not displace enough liquid to float it up. So the amount of liquid displaced in this case, initially the liquid was displaced to float both these objects. But in this case, the liquid is not displaced to float this one. That means the displaced liquid should be something less. Compared to this one, the displaced liquid should be something less in this case. So if the displaced liquid is less, you should understand uh, this should, I mean, compared to this, compared to the first, I mean, the one in H2, or I can say B, compared to B in C, this vessel should move up. So if the vessel move up, then the liquid level should go down. So comparatively, uh, H3 should be less than H2. Okay. Here, more liquid is displaced to float both these objects. So in C, it is resting in the bottom of the vessel. That means not enough liquid is displaced. So only enough displaced, I mean, only the displaced liquid volume is enough to float this one. So a lesser volume is displaced. Lesser volume displaced means this should move up. This moving up means the liquid should go down to fill the space, and the liquid level should rise down. So H2 should be lower. And when you compare uh, D, D with the second case, okay, when comparing with the second case, in D also you can see that A and B are both floating. So this vessel is already floating in all these three places. So the enough liquid was displaced. After that, A also getting displaced and enough volume of liquid to float, because it is now inside this uh, inner vessel, so it can displace an enough amount of water to float it. As well as you can see the B is separately floating on this surface. So B separately floating means it also displaces the amount of liquid which was needed to float it. So don't you see, in this case and the case in B, if you compare D and B, in both cases the liquid is displaced. Okay, the liquid inside the larger vessel is displaced such that to float all these three components, I mean, the inner vessel is floating, A is floating, B is floating. Here also, all three floating. So all three floating means the same amount of liquid is should be displaced. So if the same amount of liquid is displaced, then the height of water in both cases again should be equal. So H2 should be equal to H4, and H3 should be less. And if you compare H3 versus H1, what should happen? In H1, uh, in H1, only this vessel is floating. Only this vessel is floating, the inner vessel. So inner vessel floating means a small amount of liquid should be displaced. So small amount of liquid is displaced means there should be more gaps to fill it. So the liquid level should be the lowest. So H1 should be the lowest. I mean, you can compare, like if you add some mass, this will definitely go down and this will rise. So in all the other cases, compared with this one, in all the other cases, some mass is added. So if some mass is added, all in all these cases, this vessel should move down. That means the liquid level here should be higher than compared to the instance in A. Okay. Compared to H1, in all other cases, the height should be higher. So the variation should be given in the first answer. 27th. The satellite of mass simple m is orbiting the Earth of mass capital M and radius r. The distance from the Earth's surface to the satellite is r over 2. The extra energy needed to increase the radius of satellite to from r over 2 to r from the Earth's surface is given by. So the distances are measured from the Earth's surface. R over 2 means from Earth's surface. So the total radius is r plus r over 2. That is 3r over 2. You want to increase to up to r. That means 2r. So what is the uh, total extra energy? So here it is not the minimum energy. See, in this question, this is not the minimum energy. They ask it total energy. So what is the total extra energy? So total extra energy should be equal to change of total energy. Required total energy should be equal to change of total energy of the satellite. If you remember, the total energy of a satellite is given by minus gmm over 2r. We proved this earlier in the gravitational field lessons. So the change of total energy, higher the orbit, higher will be the energy. So minus gmm over, for the higher orbit, the radius is 2r, minus for the lower one, it is 3r over 2. So minus minus will be positive. Okay. The common denominator will be 6. So over 6r, what is the value? You can take gmm out. When you take gmm out, it will be plus. So over 6, this should be 4 minus, it is 3. So gmm over, there's another 2, right? Here gmm over 2r. So multiplied by 2. Multiplied by 2. The maximum, my mistake. So gmm is taken out. So here it is 3r, here is 4r. So the common denominator is 12. 12r. 4 minus 3. It is gmm over 12r. Percent. 28. 28. Area of two concentric metal spheres, A and B, shown in the figure are A and B respectively. Here B is grounded and A is positively charged. Okay. Which of the following graphs best illustrates how the electrostatic potential of the system varies? They should be again corrected. Various, not various. It should be vary. Uh, with the distance r measured from the center towards the outwards. Okay. So the outer sphere is rounded and the inner sphere contains some charge, is positive. So if something is rounded, then the potential should be 0. So to have the same, zero potential, what should happen? Because of these plus charges, because of these positive charges, there is a positive potential induced around this region. So there will be a positive potential developed on this outer shell because of this plus q. So a charge is induced such that the total potential is zero. So to make the total potential zero, there should be a negative potential developed by a negative charge which is equal in magnitude to the positive potential developed by the charge inside. Okay, so the radius is V here. Let's say the charge induced is capital Q. So the total potential will be 0, 1 over 4 pi epsilon. The potential given by this one is Q over V. On its surface, the radius should be the same radius. And the potential by this plus Q on this surface, when you are calculating it, that is an outer point compared to this surface. This is an outer point, so you should consider the distance to the same surface. So that is plus Q over B. It should be 0. So uh, so this thing you can cross multiply and it will cancel out, and you can find that plus Q is capital Q is equal to minus Q. That is the charge induced in the outer surface. The charge induced in the outer surface is equal to a minus Q. Okay, that is the same charge but with the opposite sign. Now you can like take the graph for the electrostatic potential. Very simple. So how to obtain? So here it is minus Q. So when you consider this area, I mean inside both these uh, spheres, the potential at any point is constant. Why? If you consider two components of potentials developed, so the potential developed by this charge is the same potential at the surface. The surface potential again compared this one also, this also exerts the same potential of the surface. So the surface potential does not change. That means the potential should be constant uh, at the values with respect to the surfaces. So it should be something like this. So inside it should be something like this. And then from here to here, I mean almost at B, the potential should be 0, right? And out of B also, if you consider any point which lies outside B, so here there is a plus Q and here on this surface there is a minus Q. So the total charge inside is 0. So if you consider point which lies outside, so compared to that point, minus Q is inside and plus Q also inside. So total charge inside is 0. That means 0 potential. So after B also there is no any variation. So if you are able to obtain these two, I mean these two variations, obviously you know if there is a potential, then that should vary inverse proportional to the radius. That means there cannot be any linear variations. So if you exclude that answer also, you can come to the answer which is the third option. So only by understanding these two areas you can come to a conclusion with this relation. Okay, because these areas are correctly represented only in two cases, which is the third option and the fifth one. In fifth one, there is a linear relationship here, but linear relationships are not expected for potential graphs because it is proportional to 1 over r. So the third option is there. Correct. Okay. That is also a good question. So maybe the next papers also get somewhat harder like this. Okay? So these are the revision papers. So we are trying to revise most of it. 29th. A particle is dropped from height capital R from the surface of Earth. Okay. So capital R is the radius, right? Is given capital R is the radius of Earth. So what speed the particle? What is the speed of particle when it reaches the ground? So it is initially 0 and now it is reaching the ground. What is the velocity they ask? So you can't apply any motion equations here. Okay. And you can't apply, mgh, like potential energy is given by mgh. That thing does not valid here. It is not valid here because why? So you can see the height from the surface is equal to a radius. So radius of Earth is a very big value. That mgh formula, the potential energy is given by mgh when this height is small, like very small. Let's say we normally say less than 100 kilometers. So Earth's radius is 6,000 kilometers. So compared to this, this is very low value. By the way, in this case, this is equal to radius. That means a higher value. So if it is a higher value, you can't employ mgh to just imply the potential energy. By the way, you have to use the correct one, which is the one we study in the gravitational fields. Okay, so you can apply energy conservation. Any other method will not be valid. You can't apply any constant acceleration, or you can say the acceleration due to the gravity is g and g stays constant and write motion equations and get the answer. That those ways does not give you the answer, correct answer, because so in this range of distances, okay, in this size of distances, g also does not stay constant. G depends on the distance, inverse proportion. Okay, so the potential at this point, gmm over 2r plus the kinetic energy 0 is equal to the potential at this point, that is gmm over r plus half mv squared, that is the kinetic energy at this point. So we write the equation gmm 1 over r minus 1 over 2r is equal to half mv squared. M get cancelled. V is equal to square root 2gm times, when you take the common denominator, it will be 2 minus 1. So square root gm over capital R, that is given in, okay. So the capital M is not given. So when capital M is not given, what is the thing we normally do? Gm is equal to gr square, right? So when you do that, you will get, you have to do this here. So when you do this, you will get, there is 1 r squared get cancelled and it will be equal to square root gr. That is the second option. Okay. And then the 30th one. 30th. As shown in the figure, the fireball displayer of a procession towards, sorry, a fireball displayer of a procession towards the fireball on a horizontal circular path of radius simple r1 with uniform angular velocity omega 1. If he shortens the radius of the path to r2 without applying an external torque, the angular velocity omega 2 of the fireball is given. Simple one, just conservation of angular momentum, conservation of angular momentum. So if there is no any external torque, the initial angular momentum should be equal to the final angular momentum, is I1. So I1, initial inertia, if the mass is m, so you can assume this as a point object. So if a point object is at an r distance from a axis, the I is given by mr squared, right? So m times r1 squared, omega 1 is equal to m times, same way you can calculate the I here, r2 squared omega 2. Get cancelled. Omega 2, if you subject it, omega 2 is equal to r1 over r2 squared times omega 1. So this is given in the second option. Okay. So At this point, we come to an end of the MCQ section. So almost consumed 2.5 hours, right? Normally, when you are discussing 30 MCQs, average time is 1 hour and 50 minutes, likewise. Okay. So this one contains, consumed a lot more time because the questions are kind of good. So yeah. So for the rest of the question paper, I think you have got already got the marking, and now I don't see that much of students are staying with this session, so no point of doing the session continuously. So I'm going to wind up the session at this point. Okay. So if I am able to find some time to do a recording for the rest, then I'll do an upload separate as a separate video. By the way, the thing is, these days I'm somewhat busy with some other work and the work related to the starting of 2028 classes as well. So after this rush time moves up, we will continue. I mean, the normal work of this paper class. So I promised you to cover like some mathematical uh, workshops, like sessions to improve your mathematical knowledge, as well as I'll be doing some practicals as well as not only that. I just promised to continue that recap sessions as well. So when I find some time, surely, I mean, after the first week of March, maybe I'll be able to start the normal work procedure. Okay. So until that, just follow your work, write the papers weekly. So right after writing the paper, you can obtain the marking and then you can compare your answers. So if you find something which can't be like uh, understood by yourself, okay, by your own, then wait for the recording. I mean, the live discussion of the paper. So even if you don't get it, I mean, even if you did not understand a certain thing, then you can directly contact me and ask the certain sections and clear out those problems. Okay. So anyhow, I mean, from these sessions, you should obtain something. So you should be responsible to obtain what you want. So this contains maybe the knowledge you already have, as well as some knowledge you does not haven't you haven't built up at this point. So it's your responsibility to get the points you haven't built enough. Okay. So I'm stopping at this point. So if there are any questions, just uh, directly contact me. All of you, I think, should have my number, so you can just ask me to WhatsApp. I mean, don't call me. I don't answer calls normally. By the way, you can just raise questions in the WhatsApp. Okay, so then, good night, everyone.